Bond polarity and dipole movement. Dipole moments happen when there's a separation of charge. So one ion will have a positive, one ion will have a negative. This can be between two ions in an ionic bond or between two atoms in a covalent bond. The dipole moment, like the size of the dipole moment, is going to depend on the difference in the electronegativity. So, how much change, like how much difference there is in the different ions' electronegativity. And the shape of the molecule plays a big role on polarity. So, just because the atoms might be polar, when you actually get the shape of the molecule, they might end up not being polar. Here I put um, a periodic table on the screen, and I showed you the electronegativity. So basically, this is F is the most electronegative. So the higher and to the right you go, the more electronegative your element is. So here's an example of a molecule. So NaN. So here's N, here's Na. So if we're following this example, you're going to go up. So N is more electronegative. So it's going to go, the arrow is going to point towards the N, but it's going to make it look like a positive plus, or a plus sign back here at the sodium. So S positive here and S negative here. And it does have a dipole moment because there's a positive and a negative charge. Here's another example. CO2. So with this one, it does not have a dipole moment because these polarities right here are canceling each other out. They're going in like opposite directions, so they're just pulling at one another. So there's not a dipole moment here because they cancel out. Another example that I have is H2O. H2O does have a dipole moment because the polarities are going in the same direction. They're not going opposite of each other. They're not pulling at each other. It's not like competition or anything. They're just going up, so they do have a dipole moment. On this slide, I've put the different types of molecular geometry shapes that molecules can have. So with linear, the bond angle is 180. With trigonal planar, the bond angle is 120. Tetrahedral, the bond angle is 109.5. Trigonal bipyramidal, the bond angle is 90, 120, and 180. Octahedral, the bond angle is 90 and 180. Bent, it's less than 109.5. Seesaw, 90, 120, 180. T-shaped, 90, 180. Square planar, 90, 180. Square pyramidal is also 90, 180. So with all of these different shapes, you'll be able to tell which one's going to have a dipole moment and which one's not. If it's not going to have a dipole moment if the angles are completely symmetrical. So like if it has a 180 in there, it's not going to have a dipole moment because the dipoles are just going to be pulling at each other. So it's just going to be a competition, and they're just going to cancel each other out. But if they have an uneven distribution charge, then there will be a dipole moment because they're just going their own way. They're going the same way. They're not pulling at each other. On this slide is some more examples, but with like a 3D figure. So this is polar, because there's positive and there's negative. This one's polar because they're all going in the same direction and it's not like this flat surface. This one is looks similar to this one, but this one is flat. It's like a planar. It's flat, so all of the moment, like the dipole moments, they cancel each other out, so they're not polar. Um, this is the same. They all cancel each other out right here. And this one's polar because it's going up and they're not pulling at each other and they aren't canceling each other out.